Hi everyone. So from today we are going to start preparation for we are starting lecture series for IIT JAM for mathematics subject. Okay, so we are starting with the very simple and interesting topic differential equation. I hope you will enjoy that topic. So the why we are starting with differential equation, since you are already familiar with this topic. You in 12th standard you have already studied it, some fundamental things, basic things you have studied. And what are the basic things are required? That is formulas of integration and derivative. So what you have to do, you have to prepare for formulas of integration and derivative. After that you can enjoy my lectures. Okay, so the main benefit of discussing that differential equation first is when we solve differential equation. Okay, so obviously we'll go through all formulas of derivative and integration, and those formulas, that preparation will help us when you discuss the topic calculus. Okay, so let us start the lecture series. Okay, so see, mainly I will focus on problem solving and some statements of very important results. Okay, so let us start with very simple topic of differential equation. Let us see. Okay, see, we are starting with very fundamental thing, that is differential equations of first order and of first degree. Okay, so order and degree of differential equation you have already seen in 12th standard, so I will not go in details, or after when we solve any difficult problem, that time we will revise that concept. So we are starting with very fundamental things. So the first type is variable separable type. I am damn sure that you have already seen this type in 12th standard, but let us discuss few simple problems and then we will go further. Okay, so I'm starting directly with the example, since this type is very easy. Okay, variable separable means what we have to do, we have to separate the variables, right? X, all terms of X we have to take on one side, all terms of Y we have to take on another side, and we have to solve the problem. Okay, so I will rewrite the problem again. I'm starting a solution here. So we have, I wrote the same problem again. Okay, so what will I do? First of all, I will shift this dx on that side. Since we have to separate the variables, we have to take dy on one side and we have to shift dx on another side. Okay, so I'm going to shift. Okay, so I shifted dx on this side. So see, so dx is here. That means all terms of x here and all terms of y we have to shift on that side. So let us try to do that. So what will I do? I can write the same thing as, so e raised to x minus y, that means e raised to x into e raised to minus y. Getting now, if base is same, you can add power. So x and minus y, you will have a power. Plus, I can write this is x square e raised to minus y dx. Right. Okay, so will you tell me what can we write now? So tell me, can I take e raised to minus y common? Yeah, obviously, I can write e raised to minus y common. I can take. So e raised to x plus x square, I am taking e raised to minus y common, and here we have dx. So see, we have on this side we have dy, right? See, dx is here, so this bracket having all terms of x should be on this side. So e raised to minus y I can shift on another side. So therefore dy upon e raised to minus y, this e raised to minus y I am shifting on this side, so which is equal to, now we have e raised to x plus x square dx, right? So this e raised to minus y, it has a negative sign, so if you shift to the numerator it will have a plus sign. So e raised to y dy is equal to, see, now we have separated the variable. Okay, so all terms of y we have on this side, all terms of x on that side. So now we can integrate. See, I'm integrating both sides. So what will I have? Integration e raised to y dy, and I can integrate this side also. Okay, so do you know integration of e raised to x or e raised to y? I will write a formula here. See, integration of e raised to x dx is e raised to x, and integration of x raised to n dx is x raised to n plus 1 upon n plus 1. Okay, these are two formulae we have, so we can apply. So what is integration of e raised to y? Obviously it is e raised to y only. Here addition is there, you can take separate integration. Integration of e raised to x is e raised to x, and integration of x square, for x square I can apply this formula. At a place of n we have a 2, so integration of x square is by this formula x raised to 2 plus 1, that means x raised to 3 divided by 2 plus 1, that is 3 plus c. So this is required solution of given differential equation, right? Okay, so let us try to solve this second problem also. Okay, so this is our second problem and this problem we have to solve. So what will I do? I will write the given problem again. I will write the problem again. Okay, so you remember now what we do in case of variable separable type. So we take all terms of x on one side and all terms of y on another side. So that's why this dx I will shift on that side. Okay. Okay, so I have shifted dx on this side. See, one thing, that dx is here, that means all terms of x should be here, and dy is here, that means all terms of y we should shift on that side. So how many terms of y we have? Here is y, one term of y we have got. Here also we have one term of y. So what will I do? So I can write the same thing as e raised to 3x into e raised to minus 2y. In this way you can separate. Base is same. Now if you add powers you will have the previous thing, plus x square e raised to minus 2y dx, right? So tell me, can I take e raised to minus 2y common? Yeah, obviously I can take e raised to minus 2y common. So this is e raised to minus 2y, I am taking common. So we have here e raised to 3x and here we have just x square dx. So that's why we have dy is equal to, see what can we do? All these are terms of x, here we have one terms of y, so I will shift this term on this side. Okay, so I will shift e raised to minus 2y on this side of dy. Okay, so I have shifted this e raised to minus 2y on this side. So see, this is in denominator. If you shift to the numerator, it will be e raised to 2y. Power will get changed, sign of power will get changed. So this is dy is equal to, I will copy the same thing here. See, in this way we have separated the variables, right? All terms of y we have got one side and all terms of x we have got on another side. So now we are ready. That means we can take integration now of both sides. So I am integrating both sides. Okay, I am taking integration of both sides. Integration of left hand side I have taken. Similarly, I will take integration of right hand side. Okay, so now we have to take integration of this e raised to 2y. So for that we should know the formula. See, integration of e raised to x dx is equal to integration of e raised to x upon a. So this is a formula we have, right? This is a formula. So that means whatever the coefficient of x we should write at denominator. So let us apply this formula to take this integration. See, its integration will be e raised to 2y upon 2, since as a place of a we have a 2. So this is equal to, if you take integration of e raised to 3x, e raised to 3x upon 3 plus what is integration of x square. See, to take integration of x square we have this formula. Integration of x raised to n is x raised to n plus 1 upon n plus 1. So can you tell me using this formula what is integration of x square? Yeah, n is equal to 2 now. So if you put n is equal to 2, we will have x raised to 2 plus 1, that means 3 upon 3. 2 plus 1 3, right? And c is the constant of integration. So this is a solution of given differential equation. Thank you.